All right, so we got Chuck here. We're in PCI 264. All right, Chuck's been working on, along with the other classmates, he's been working on Studio 5000. We have a 3-phase motor, and we're interfacing with this Allen Bradley 525 motor drive, and then we're also interfacing with this Automation Direct's Seymour panel. Okay, so Chuck, tell us a little bit about what's going on and what the process is, if you don't mind.
All right, I guess so. The first thing we did was I set up with Studio 5000. We created a program where we wrote ladder rungs to cause the motor to go the way that we want it to go. We set up timers where it's basically going to turn on the motor, go forward for 15 seconds, stop for 15 seconds, then turn on again and go back the other direction.
Okay, so kind of like a mixing process or something.
Exactly. Then we set up, we used Seymour program to create a HMI screen.
Okay.
Up here.
And what do we have on the HMI?
And these are the buttons to interact with it. We got start, stop, clear for clearing faults, increase to change the speed of the motor, and then reset to basically bring everything back to zero with the timers.
Okay. So initially, every time we learned that when we interface with this HMI or with this Allen Bradley 525, every time the PLC would download and go online, it would actually fault the controller here. So you have to have a clear fault instruction, and that's actually what that's for. So his start button is going to be used to just start the process. Obviously his stop is just to stop everything. And with the increase, what are you doing with that?
We're able to actually change the hertz, which we should be able to see on this once we get the faults cleared.
Okay.
And see which changes the speed of the motor.
So normally a motor would run at what?
We usually have these set at 60 hertz.
60 hertz, yeah. So we're going to actually start it off at
40
hertz. Okay.
And then we can bump it up.
All right. So yeah, let's see it.
Shot here.
All right. So he's going to hit start.
Oh, that's the clear faults, I think.
Clears faults. Have a stop button on.
And stop button on. Yes.
And you'll see here that the motor actually started. Okay. So it should run for about 15 seconds.
Yeah, we might have skipped a few of them.
Yeah, probably skipped it from where we had to start before that.
So
then now it'll do a 30-second period break here.
15-second
break.
So we changed it.
Yeah. And then we'll just kind of watch the frequency here. And you'll see that the motor's actually turning in reverse now. And then what are those lights for, Chuck?
Speed here first.
And he increases the speed. Do it again.
Change the hertz.
Yeah, it's fine.
There.
So you can see them going up and down there.
And we have a run and a ready light, which
Okay.
I'm not even sure are working correctly at the moment. But
Right.
good enough. And it's going to shut off maybe at the end.
All right.
Maybe not.
So let me ask you this. If that motor's running at 60 full hertz, what kind of amp draw should we be getting?
Now you get me in trouble. Yeah. So 60 hertz, what do we got? Let's see. Let's take a look at the motor. See what we got here.
So we're using 208 voltage,
and
it looks like we're 1.8. All right, so we don't have a load on it.
60 is the average.
Yeah, we don't have a.
Seeing a little bit lower.
Yeah, because we don't have any kind of load on it. But if we could we restart this again?
I think we can.
All right.
We can hit reset. Stop. Let's see where the stop is.
Okay.
And we're gonna. So now it's ready.
Okay.
And we can go ahead and start.
All right. So check your current on one of them leads there when we get to 40 hertz, and let's just kind of see what our current is.
And see. Throw it on there.
So you can see that it's about 1.08, and as we increase it a little bit, it increases. But the timer actually cut us off. Yeah, the timer actually cut us off before we could have that. But you'll notice as we decrease in hertz, what's happening is we're decreasing in current, we're also decreasing in voltage. So, good job, Chuck. Appreciate it.
Good.